Hello, my name is Nathan Arakawa. In this video, I will be showing you how to find the absolute value of a complex number. Before I explain to you how to find the absolute value of a complex number, let's do a quick review of complex numbers. Complex numbers are numbers that are expressed in the form a plus bi, where a and b are real numbers and I is the imaginary unit, defined as the square root of -1. Complex numbers are also the sum of a real number and an imaginary number. An example of a complex number is 5 plus 2i. Here we can see that 5, a real number, is being added to 2i, an imaginary number. The sum of these numbers is a complex number. Complex numbers can be graphed on a complex plane. A complex plane consists of a horizontal axis representing the real numbers and a vertical axis representing the imaginary numbers. Using the example 5 plus 2i, we can graph the complex number 5 plus 2i. 5 plus 2i can be graphed by going 5 units right along the real axis and by going 2 units up along the imaginary axis. This point on the complex plane is the complex number 5 plus 2i. In this video, we will be looking to find the absolute value of a complex number. This is the distance between that number and the origin on the complex plane. This distance is represented by the variable z. We can find this distance using the equation the absolute value of z equals the square root of a squared plus b squared. In this first example, we are told to find the absolute value of 6 plus 7i. Let us graph this complex number first. 6, 7. The complex number 6 plus 7i is located here on the complex plane. Because we know the form of a complex number is a plus bi, we know that a equals 6 and b equals 7. As a result, we will substitute these values into the equation that I mentioned earlier. The absolute value of z equals the square root of a squared plus b squared. I'm going to substitute 6 for a, and I'm going to substitute 7 for b. The absolute value of z equals the square root of 36 plus 49. The absolute value of z equals the square root of 49 plus 36, which is 85. Because we are no longer able to simplify this radical further, the absolute value of 6 plus 7i is the square root of 85. In this second example, we are told to find the absolute value of 2 minus 4i. Let us graph this complex number first. On this graph, we know the complex number 2 minus 4i is here. Because we know the form of a complex number is a plus bi, we know that a equals 2 and b equals -4. And because we are looking for the absolute value of this complex number, which is the distance from the origin to the complex number, we are going to substitute these values into the same equation as the last example. The absolute value of z equals the square root of a squared plus b squared. I'm going to substitute 2 for a and -4 for b. 2 squared is 4, and negative 4 squared is 16. That equals 20. Because 4 is a perfect square and a factor of 20, I can simplify this radical. After solving this equation, we now know the absolute value of the complex number 2 minus 4i is 2 rad 5. Thank you for watching my video. I hope this video has helped you learn how to find the absolute value of a complex number. Thank you and have a good night.